Okay, in this problem number 10, they're just describing a preference schedule but in words. And so we want to read carefully what they're saying here and write down a preference schedule table. So first, if I'm thinking how big should my table be, it looks like there's 3 candidates A, B, C. So at the very most, there's going to be a first, second, and third place. And then when I'm looking at how many columns to make, I don't really know yet because it's how many people had the same type of ballot. So maybe there were lots of different ballots, maybe there were only a few different types. But if I end up with some extra space, it's no big deal either. So I'll just make myself a few columns so I have some space. Okay, 20% of the voters like A the most and B the least. So there's a column. I'll just write this on the bottom. Since 20% isn't a number of voters, I normally think we like a number of voters up here, or the number of votes they got. So 20% of them liked A the most and B the least. Well, if I liked A the most and B the least, figure out where C has to go because there's only one spot left. And then 40% liked B the most and A the least. So B the most and A the least, which means C is in the middle again. And that was what, 40% of the voters? And of the remaining 225 voters, and so picture they're not saying 225 people. Oh no, they are. Of the remaining voters, 225 of them prefer C to B and B to A. So on this one, they told us the actual number, so I can just write, 225 people had a ballot that preferred C to B and preferred B to A. So in this order. And 675 prefer C to A. So one more column. So 675 voters prefer C to A and A to B. Just make sure we're reading that carefully. C to A and A to B. Okay, so how can I figure out how many voters went up here? It's the only thing I don't have filled in the table, right? Well, notice this represents what, 60% of the total voters combined because it's 40 and 20, which means this must be the other, what, 40% of voters? So if 225 plus 675, which is what, 900, if 900 represents 40%, what's the whole thing? And so think normally, if I know the large number, I want to multiply by a percent. So let's say I did know the total number of voters. I'll even just write it as total instead of a variable. If I knew the total number of voters and I multiplied by 40%, I'll write our percent as a decimal, right, when we go to use it. If I knew the total number of voters and I multiplied by 40%, it would give me this, because this represents 40%. It's not the whole thing. The whole thing is what we want to know. And so 225 plus 675 is 900. Just making some room so we can see this is separate. So if I want to know the total times 40% equals 900, what can I do to both sides to get the total by itself? I'll divide both sides by 0.4. And we'll do some checks on this in a second to make sure, just so you can see how the percentages work out. So 900 divided by 0.4 is 2250. So I just figured out by solving for it that the total number of voters is 2250. Okay, well, how does that help me get the rest of this? Well, if I know that the total, I guess I should have left that one there. If I know that the total number of voters is 2250, and I know 20% voted this way and 40% voted this way, then what I want to know is, what is 40% of 2250, which you can tell we just kind of did that only backwards, but we'll just check on it. So 40% of 2250 should be 900. You can check in your calculator. So this is 40% of voters. And so then 20% of 2250 should be half as much, but check it in your calculator. So 0.2 times the total number is, what is 20% of this total is 450. Alright, so then here's my big check that I'm going to do. If it was supposed to be a total number of 2,250 voters, let's check and see if those numbers I have across the top actually add up to 2,250. And obviously you can add in your calculator too. I'm just going to, maybe I'll add by hand here just so you can see it on it. So 450 plus 900 is what, 1350? And then 225 plus 675 is 900. And 1350 plus 900 sets to 12. Carry one over here is 2250. So basically you're using the idea that if they ever tell you a percent, if they leave one out, you know that the whole thing has to add up to 100%. And so here you had to solve for 100%. I think the homework problem number 9 is actually a little shorter than that. You don't have to fully solve for the percentage.